Welcome to another pre-calculus video. Here we are going to continue section 4.1, day 2. Here you're going to see a different way to measure angles called radians. And the book says a second way to measure angles is in radians. This type of measure is especially useful in calculus. In calculus, we never use degrees, it's always radians. To define a radian, we can use the central angle of a circle, one whose vertex is the center of that circle. So I think I got it over here in a picture. So here, notice this length is, of course, our radius. And what if we swept out a curved arc that was exactly equal to the length of the radius? So again, let me highlight this in red. What if we took this radius length and bent it and put it along the edge of a circle? The angle that cuts out is 1 radian of angle, or 1 radian to measure. So here our S, that's the length of this arc. If I put dots here, that bent arc is exactly the same length as the radius of the circle. That gives us a central angle of 1 radian. So 1 radian is the measure of the central angle theta. That's the Greek letter theta right there. It kind of looks like a 0 that's kind of wearing a belt. That central angle that intercepts arc S equal in length to the radius r. Algebraically, this means that the angle theta is equal to S divided by the radius. Angle theta is measured in radians. Because the circumference of a circle is 2 pi r units, it follows that the central angle of 1 full revolution corresponds to the arc length of S equals 2 pi r. So let's see here. Let's just a little column compare and contrast. Degrees are easy because we've been using those for a while. A full circle is 360 degrees. That's going to be exactly the same as 2 pi radians. Most of the time radian measure will have a pi in it somewhere. Not always, but usually. So let's see. If we cut a circle in half, half of 360 is 180. So half a circle is 180 degrees. In radians, that would be 1 pi. Half a circle is pi radians. If we cut 180 in half, we get a right angle, 90 degrees. I should have degree signs on here. And then to cut our radians in half, that would just be pi divided by 2, or half pi. So again, a full circle, 360 is 2 pi radians. A 90-degree angle is half pi. And a half circle is pi, which lands right in the middle. So here, this is the picture we saw before, so we're not going to talk about that one again. But here's a different one. If we keep going around, here is 1 radian. And if we keep going, another same length, there's 2 radians. And if we get a little bit more, there's 3. Notice there's that little gap between the negative x-axis and that angle there. Well, remember, half a circle is pi, which is approximately 3.14. So if 3 radians took us there, that little bit more we got to go is the 0.14. And if we keep going, here's our 4th radian, here's our 5th radian, here's our 6th radian, and notice that gap there is a little bit bigger. Well, if we go all the way around a circle, that's 2 pi radians, and 2 times pi is roughly 6.28. So that's why there's that little gap left in there, that 0.28. 2 pi radians is a full lap around the circle. Okay. Here it wants us to find some angles, find each angle, the complement of this, the coterminal with that, the supplement of something else. Now I put up here in some different colored ink. Remember, complements are 2 angles that add up to 90. Or we'll take 90 and subtract our given angle. Well, for a complement, 90 degrees is the same thing as pi over 2 radians. So for part A here, to find the complement of this angle, complements add up to 90 degrees, or now with radians, that's pi over 2. So we're going to take pi over 2 and subtract the angle they gave us, pi over 12. Just like with degrees, we would do 90 minus the given angle. Now it's pi over 2 minus the given angle. Well, it looks like we're going to need a common denominator. So I want to get a common denominator 12, so I'm going to multiply this one do it like this. Multiply top and the bottom by 6. So now that's going to be 6 pi over 12 minus 1 pi over 12. 6 pi minus 1 pi, well, that's 5 pi. 5 pi over 12 is our complement, the complement of pi over 12. So if we wanted to draw that, here would be the pi over 12 angle. And then we would want to know how many more radians to get back to the positive y-axis. Well, that would be our 5 pi over 12. If we add them up, we should get pi over 2. All right. Letter B is asking for a supplement. Remember, for a supplement in degrees was 180 minus the given angle. Well, in radians, 180 degrees is 1 pi radian. And from that, we're going to subtract the angle they gave us, 5 pi over 6. 5 pi over 6. So for our common denominator, 1 pi would be 6 pi over 6 minus 5 pi over 6. Numerator, 6 pi minus 5 pi is 1 pi. Pi over 6. So if I draw this, 5 pi over 6, that angle would open up from the positive x-axis to here. So this would be 5 pi over 6, and then the complement is how many more radians to get back to the x-axis. In this case, it's just pi over 6. If we add those together, we get 1 pi, because the definition of a supplement are two positive angles that add up to 180, or 1 pi radians. Okay, now this last one, coterminal angles. So we're starting here with a pretty big one, 17 pi over 6. Well, a full circle is 2 pi radians. So we can either add 2 pi or subtract 2 pi. Well, this is a big angle to begin with, so let's subtract 2 pi. So let's see, we need a common denominator. We're going to multiply top and the bottom by 6. So if I multiply my denominator by 6, that becomes a 6. Numerator, 2 times 6 is 12. So that's 17 pi minus 12 pi. Well, that's 5 pi, and it's over to common denominator, 6. So there is get out of there, teams. There's one of our coterminals, and that's a positive. We could subtract another 2 pi to get a negative, or I could go back to my original. If we want another coterminal, I could just make that a plus. If we add another circle, that would become 17 pi plus 12 pi. That's 29 pi over 6. So these are all complementary angles to the original 17 pi over 6. And that's it for example 3. What do we got next? Converting between rads and degrees. It's actually a very simple formula. And let me take the moment to say this is something that could be on the SAT test. Every now and then, a student on the SAT test will get a conversion question, convert usually from degrees to radians. And notice here, to convert degrees to rads, it's pi radians over 180. If we're converting in the other directions, rads to degrees, we just flip it upside down. And I'd like to point out here, whatever they give you goes into the denominator. Here they give you degrees to convert. That means the 180 degrees is downstairs. And you'll see why that's important when we do an example. If they give you rads, the rads go in the denominator, the degrees in the numerator. And again, you'll see why in the upcoming example. Example number 4. So here we go. 135 degrees, they want us to convert into radians. So what I like to do, I'm going to put that 135 degrees over 1, and we are going to multiply. I'm just going to rewrite it here. 135 degrees over 1. We're going to multiply by, since they gave us degrees, we want the 180 degrees in the denominator, and then the pi up top. And then once it's on the diagonal like that, the degrees cancel. The degrees are units, and the degrees cancel away. So this up top here is pi radians. That's our new units. If we multiply straight across, we get 135 pi over 180. which is technically correct, but it's not as nice as it could be. Let me back up. I'm going to steal one of these calculator slides. Oop, that was in the other slideshow. Okay, I went to the other slideshow and stole one of these calculator slides. These calculators can also reduce fractions. This 135 over 180, it's obviously divisible by 5, but to reduce it down all the way might take a little time. Notice all the way on the bottom here left, right by this left arrow key, you got that thing right up above it. It says F, and there's like a little triangle pointing toward the F, and there's another triangle pointing to a D. That is our fraction to decimal conversion key. So a neat thing we can do on this is convert this 135 over 180 into a nicer fraction. It'll reduce it for us. So what we want to do first is divide. You're going to type into the calculator 135 divided by 180, and you hit equals, and it gives you some decimal. Now, if you take that, or just leave the decimal there, hit the second function key, and then hit the F to D conversion, fraction to decimal, and the display is going to look like this. On your calculator, you'll see a 3, and then like a little backwards L and a 4. So that's 3/4. 135 over 180 reduces down to a 3/4, and then don't forget we got to put that pi back on there. 3/4 pi radians. So there's our conversion. Oops, get out of there. 135 degrees is the same thing as 3/4 pi radians. Let's do it again. 540 degrees. So we've got 540 degrees over 1 times pi radians over 180 degrees. So again, the degrees cancel on the diagonal. So what we're left with is 540 pi over 180. And we can drop the zeros, and actually this divides perfectly. 54 divided by 18 is 3. So that becomes 3 pi radians. 540 degrees is the same as 3 pi in radians. Now, what if it's a negative angle? It's still the same. Nothing's going to change. Whoa, why do I got 2 of those? Okay, so negative 270 over 1. We're going to multiply that by pi radians over 180 degrees. And then, of course, our degrees cancel. And we can even drop the zeros. So what it looks like we have is negative 27 pi over 18. Now, we could do that same trick on the fraction, but I'm looking at these and I see they're both divisible by 3. So 9. 27 divided by 9 is 3. 18 divided by 9 is 2. So that's negative 3/2 pi is the same as negative 270 degrees. Now again, here they gave us degrees, so the fraction we used had the pi rads on top and the 180 degrees in the denominator. When we convert the other way, here we have radians, we're going to convert into degrees, so we're going to flip that other fraction over. So here we've got a negative pi over 2 rads. We're going to multiply that by 180 degrees over pi radians. So now the radian measure will cancel. These pi's will cancel 2 1s. Don't lose track of the negative. So it looks like we have negative 180 degrees over 2, which is negative 90 degrees. All right. Next up, 9 pi over 2 rads. So, of course, we'll have our 9 pi over 2 rads. We're going to multiply that by 180 degrees divided by pi radians. So on the diagonal, the pi's will cancel. And it looks like, well, this is, well, we could multiply straight across, but we can reduce on this diagonal. If we divide the diagonal by 2, 2 divided by 2 is 1, and then 180 divided by 2 is 90. So that becomes 9 times 90, and that is 810 degrees. So 9 pi over 2 rads is the same as 810 degrees. Now, I mentioned earlier that most radians have a pi in them somewhere, so they usually stick out, but this one doesn't. Whoa, there's another one there. Okay, get that out of there. Pi are just 2 radians. So here we are going to have 2 over 1 times 180 over pi. Now notice pi is not going to cancel, but that's not going to stop us. We're just going to multiply straight across. 2 times 180 is 360. And then 1 times pi is pi. And then we can just punch that in our calculator. 360 divided by 3.14159 is approximately, we got to round off here a little bit, 114.5916 degrees. So usually the pi is going to cancel, but in this case it didn't. You know, we knew it was in radians, and we just had to divide by pi at the end. Not a big deal. Okay, time to pause the video and try these huddle problems, and then fire it back up and see if you got them right. Okay, 52, it says sketch the angle in standard position. So I'm going to draw my xy axis, and my first one is negative 7 pi over 4. I like to convert these into mixed numbers, so that's going to be the same as negative 7 divided by 4 is 1, and then a remainder of 3 makes it 1 3/4. Negative 1 3/4 pi. Remember, when you do half a circle, it's 1 pi. So if I go this far, that's 1 pi, and then another one is 2 pi, and then 3 pi, and 4 pi. But now we're going in the negative direction, so we're going to start on our initial. This would be negative 1 pi, negative 1.5, negative 2. So if I've gone that far, I've gone too far. I need negative 1 3/4. So here's negative 1, negative 1.5, 1 3/4 is going to stop right about here. And if we think about it, another quarter pi would take us all the way around to 2. This is very close to being 2 pi. We're only 1/4 off, so that's this missing gap. So there is negative 7 pi over 4 drawn in standard position. Letter B, 5 pi over 2. Well, 5 divided by 2 is 2, with a remainder of 1. So that's 2.5 pi. So I draw my xy axes. And this is in the positive direction. So if we do just this part, the 2, that's going to take us a lap around the circle. So now we just got to go another half pi. And remember, half a circle is 1 pi. So if we go to the next axis, that's another half pi. So here's our terminal side. A lap around and another quadrant is 2.5 pi radians. 53. Sketch this, oh, I guess that's under the same directions. Sketch this one in standard position. So let's see, 11 pi over 6. If we divide 11 by 6, that's 1 with a remainder of 5. So that's 1 5/6 pi. Here's my xy axis. So if we go this far, that's 1 pi. And then 5/6 is almost another full pi. So we're going to go almost back to the x-axis. We've got a sliver left out. Because remember, a full circle all the way around would be 2 pi. We're almost to 2 pi. We're 1/6 short. So there's what our graph is going to look like. Almost a trip around the circle. 62. Complement and supplement if possible. So just a little scratch work here. Remember, complements are going to add up to pi over 2. Supplements add up to 1 pi. So for letter A, the complement is going to be pi over 2 minus the given angle pi over 6. And the supplement is going to be 1 pi minus the given angle. Okay, so let's do this complement first. We need a common denominator of 6. So if I'll do it like this, if I multiply the denominator by 3, 2 times 3 is 6, so I got to multiply my numerator by 3, so that's 3 pi over 6 minus 1 pi over 6. 3 pi minus 1 pi, that's 2 pi. 2 pi over 6. And then we're going to reduce the 2 6 down to 1/3. 1 pi over 3, 1/3 pi is our complement. Now the supplement I think is a little easier because this is a 1 pi here and we want denominator 6. So that's just going to be 6 pi over 6 minus 1 pi over 6. 6 pi minus 1 pi, that's 5 pi. 5 pi over 6 is our supplement. Letter B, 3 pi over 4. So our complement is pi over 2 minus 3 pi over 4. So remember, pi over 2, that's a 1/2. This is 3/4. If we subtract that, we're going to get a negative answer. Remember, we have to have positive angles, so this angle has no complement. No complement. So, but for the supplement, we're going to do 1 pi minus the given angle, 3 pi over 4. And turning 1 pi into fourths is easy. That's 4/4. 4 pi minus 3 pi is 1 pi over 4. So that is our supplement. Pi over 4 is supplementary with 3 pi over 4. Add them up, you get half a circle. 81. This one, convert the angle measure from rads to degrees, round to 3 places. So here's the angle they gave us, 15 pi over 8 radians. Because we've got a rad or a pi up here, our fraction will have pi in the denominator, 180 in the numerator. So the pi's are going to cancel, the radians are going to cancel, and it looks like we just got to multiply straight across. We're going to have 15 times 180 in the numerator. We will get that. We're going to divide that by 8, and that turns into, well, we don't have an approximate here. This is exactly equal to 337.5 degrees, or do 0.5. 337.5 degrees. If it says 3 decimal places, I could guess we could make it 0.500 degrees if we want to stick exactly to the directions. Okay, I believe that ends the day 2 stuff. Oh, let's do one more here. Sketch them in standard position. A lot of students, since this is new, this is the hard part here. Just start thinking as we go around the circle. This is 0 rads. This is 1/2 pi. This is 2/2 pi. And this is 3/2 pi. And that would take us all the way to round to 4/2 pi. So there, if we count by halves as we go around hitting each of the axes, might be a way to keep this a little clearer in your head. So our first one, negative 7 pi over 4. Convert, that is negative 1 3/4 pi. So negative 1 3/4, well, here's negative 1/2, negative 1, negative 1.5, and if we go more, that's negative 2. We've gone too far. So we're going to back up. That's going to put us in the first quadrant. So again, here would be negative 1, and then negative 3/4 almost takes us to negative 2. 5 pi over 2, we'll divide 5 by 2. That's 2 with 1 left over. So this is 2.5 pi. Well, the 2 pi is easy. That's 1 lap around. There's 2 pi. And we want to go another half, so that's just going to take us to the next axis that we hit. Positive y-axis. Here's our angle, sketched in standard position. 11 pi over 6. 11 divided by 6 is 1 without going over, and there's a remainder of 5, so that's 1 5/6. Notice that's just under 2. If we add another 6th pi, we'd get to 2. So we're almost going to do a full lap. Here we are at 0, 1/2 pi, 1 pi, 1.5 pi. Here we're almost going to get back to 2, and we stop. So it's going to look something like that. Definitely in the fourth quadrant. And that's enough for this video. Maybe we'll do these in class, and we'll also have plenty of odd problems to do. So hop on to WebAssign 4-1, day 2 for the homework.